as a company, our logo is actually, or our motto is we're the architecture for the digital world, meaning that most of the devices that you probably have around your home, in your pocket, we would like to have that be ARM-based. And all of you probably own ARM devices already, you just may not be aware of it. If everybody has a cell phone, you have an ARM in it. If you have an iPhone, you have 13 ARMs in it. So, ARM today is shipping about 20 billion chips total, and this year alone there will be about 7 billion ARM-based devices that have been shipped from our partners, used by OEMs all over the world in all sorts of devices. So, the vision that ARM has, and again I'm going to read this verbatim simply because this is all of our literature. So we want a world where all electronic products and services are based on energy efficient technology, and that's a big thing because these are the buzzwords in politics. These are the buzzwords around design circles. Energy efficiency is king because things are getting smaller, more mobile, and you want something that you don't have to worry about plugging in. You want something that's very energy efficient, and ARM and our partners are developing all of that technology today. So if you took, and I'll give you a little bit of background about what we do. This is, say, a standard device, something like a GPS system, or it could be digital camera, maybe it's a smartphone. If you actually stripped away that top layer and looked at the printed circuit board underneath it, there's generally about 3 or 4 big system-on-chips. These system-on-chips can be designed and built by all of our semiconductor manufacturers, so Texas Instruments, Samsung, Qualcomm. And if you take a look at one of these devices, and again, this is why ARM really doesn't get a lot of press, or as far as students, it doesn't get a lot of publicity. The chip itself is built by one of our partners, but it doesn't typically get seen by the end user. But if you open up the system on a chip and you look at the device itself, and again, I'll give you an example. So let's suppose that this is a cell phone, and this particular chip has custom logic that's been designed by the cell phone manufacturer. It also has an ARM processor in it. So ARM specifies the processor at the RTL level. We design the brains of the chip. We also design some of the periphery components that go around the brains. So we design the LCD controllers and timers and UARTs and all sorts of good things. So this chip, in fact, can be built by a number of partners. So let's suppose that this is a GPS device. Well, if the GPS manufacturer goes to a silicon vendor, they can go to any number of silicon vendors. They can go to HP, they could go to TI, they could go to Samsung, Qualcomm, anybody that they want. And all of those partners can build that exact same device because they all have ARM licenses. So these are the parts that we specify. We also specify the components down to the transistor level. So ARM specifies and designs standard cell libraries for most every foundry, TSMC, Global Foundries, Samsung, etc. And then we also specify some of the development tools that allows this partner to build this system more quickly. And then what we call the connected community. These are all of the partners that you see around you today. So the connected community is the set of support, the set of partners that provide the support that comes with building that device. So the operating system manufacturers, tools vendors that help with synthesis, place and route, all the folks that make the debuggers, so Yokogawa, things like that. So we call all those partners the connected community. So ARM was actually started back in a barn, and you always hear the story about how Apple was started out of a garage, HP was started out of a garage. This is our barn. It was a very nice barn. It was air conditioned and everything. And we had about 12 employees at the time. The founders are still mostly with us. We have 8 out of 12 of the original founders still with us. We now have about 24 employees worldwide. We went public back in 1998, so we've been a publicly traded company since then. You'll notice that in just a second I'll show you who all the partners are. We have an annual partners meeting every year where we invite everybody to see the next generation of technology coming down the pipe. At our first APM we had about 8 partners. The last one that we had the one we had in 2010, we had over 400 partners. This was the first part that was produced. The interesting thing here is that this part worked right out of the chute. So when they designed it, first silicon actually booted up. This was back in 1985. So 2 years, actually 4 years after the original papers were produced by independently by Hennessy and Patterson and Carlos Seguin, sort of inventing this new thing called RISC, or the Reduced Instruction Set Computer. So this is still relatively new technology back in the 80s. Since then, it's changed quite a bit, and I'll show you some of the examples of modern systems. Our business model is a little bit different. So rather than purchasing a chip from a company like ARM, we provide the IP. So in effect, we sell the recipe for building systems, and we let everybody else do the cooking. Usually the products come out of research, the R&D group, which is where Joe and I are based. So after about 2 or 3 years of development, it'll go into commercial production. The partners will then take those designs. We get a license fee up front, and then based on the number of parts that are sold, we get royalties back from that. So we have 2 income streams. We have 2 revenue streams. One is from licensing, and the other one is from royalties. And then over 20 years or so, you have lots and lots of products that are produced based on all of these devices that have been in industry. In fact, the ARM7 is now 15 years old, and it's still being used very heavily in devices like Bluetooth. So if you have anything with Bluetooth in it, you have an ARM7. So these are all of our partners. If you look in the center, these are, the first slide, you'll see the silicon partners. And these are represented by the folks here. So silicon manufacturers, as far as who's building ARM-based systems, it's literally everybody except one person, or one company. And that's Hitachi, only because they have a competing architecture. But all the other companies are represented here. So all of these companies that are producing silicon that you can get your hands on, like NXP, we have TI, we have Xilinx. So these manufacturers are for research. These manufacturers are all producing ARM devices. We have design support partners, and again, these are companies like EDA companies, the Cadences, the Magmas, the Mentors, Synopsises, these sorts of design support partners that help the OEMs produce something. And then we have software and consortia partners, so all the operating system vendors, folks like QNX. So we have all the major operating systems ported to ARM, and in fact, you've probably even seen a lot of press in the last, say, 6 months about Microsoft porting the next generation of Windows. Windows 8 has actually been ported to ARM. There are different types of licenses, so not everybody gets the same thing. And if you look at probably the bulk of the licenses that are taken, they tend to be either implementation or term licenses. So what this means is that as a company, let's say I'm a startup and I would like to produce a bit of silicon that has an ARM in it. Well, I can go back to ARM and I can get a term license that allows me to build one device in a particular way using one of the ARM parts. So for example, a Cortex A15, I will go get a license for a Cortex A15. I will build one type of product out of that, and then I will, that's the terms of the agreement. If you look at the very top, so we don't do a lot of these, but there is something called an architectural license. And an architectural license allows companies like Qualcomm to build an ARM processor without using ARM's technology, without using our engineers. It's using their engineers. They have to fall within certain guidelines, they have to follow certain rules, but they can build a 24-stage pipeline if they choose to build it that way. That's up to them. So there's not a lot of companies that have architectural licenses, but they exist. Now, the academic licenses, those tend to be somewhat specialized as well, so sometimes for research programs we can license some cores, not all of them. But the bulk of them tend to be implementation licenses that our partners take. On the physical IP side, now these are standard cell libraries, we have, again, something of a slightly different business model in that the libraries can be downloaded for free and then used in evaluation, and then at some point the user would have to come back and take a licensing agreement for the libraries before they were actually manufactured. So what is driving all of this growth? What is driving the whole the ecosystem that's changed so radically? If you go back, and again I'm dating myself, if you go back to mainframes like an IBM 360 or a VAX or an Amdahl, do you guys by chance have any of these? Is there a computing museum at RIT that you can go visit? If there's not, I would recommend go to the Smithsonian, have a look around at the Museum of Science, and I believe they actually have, I know they have an old IBM, and I think they have